Okay, so now we are going to start looking at how you actually drive the digital I/O with your Arduino, and we're going to start by driving a very common circuit, which is an LED indicator light. So an LED is a light emitting diode, and you probably see these in all your electronics. The BOE kit comes with these red LEDs, and what we're going to do is we're going to put this circuit right here off of pin 13 and off of pin 12 of the Arduino digital I/O. And what we want to do is put a 220 ohm resistor and a red LED in series to ground. So a couple things to bear in mind here. The resistors that you get in this kit are color coded, and we want a 220 ohm one. So the way that you look these up is you use the resistor code color codes. And for a 220, it's going to have a code of red, red, brown, and that stands for 2, 2 followed by 1, 0. So in your kit, go ahead and grab two of these red, red, browns. And then you're going to connect that in series with an LED. Now the way that an LED works is it's actually polarized, so it's got a plus and a minus. The plus lead, which is, they call it the anode, is indicated by a longer pin, and then the cathode, which is the shorter one, is indicated by a shorter pin. So what you can do is you can actually use the prototyping area of the BOE shield to do this connection. So here's an example. The digital I/O are brought out to this this connector from the Arduino, and they're labeled over here digital, the pin number 13 and 12. And what they did is they just stuck the resistor directly in the connector and came over into this prototyping area. And remember that on the breadboard, these 5 are connected. So if you put the resistor lead into that hole and then you put the LED hole or lead into that hole, they're connected. And then what they did is they wired it down to here and then put it down here and picked up ground there. So what I did is you can actually stretch these over, and you do it without wiring. So you just got to keep in mind that the longer lead of the LED connects to the resistor. So there you have it. That's how you're going to wire this up. And what we're going to do now is we want to write a program to turn these on and off. So the way that you do it is there's two instructions or two functions that we're going to use, and the first one is going to be called pin mode, and it's how you set up an Arduino digital output to be either an input, or excuse me, an I/O pin to be either an input, an output, or an input that has a pull up resistor on it. So don't worry about that right now, we're going to do it as an output. And then all you do is you use a function called digital write, and you just tell it what pin you're going to write to, and then you give it a high or a low. Now in a digital signal, high means it's going to typically be a high voltage, the highest voltage that the Arduino uses, which in this case is usually a 5 volt. It can also be a 3.3 volt on some systems. And a low is going to be the lowest voltage, which is going to be 0 volts or ground. And what's neat about it is that it's either going to be one of these two values. And within the program, we use high or low, and we don't really even care about whether it's at what voltage level it's at. We just want high to turn on the resistor LED circuit and a low to turn off the LED resistor circuit. Okay, so let's go ahead and do this. So what I'm going to do is I'm going to fire up a new Arduino sketch, and the first thing I'm going to do is I'm going to go ahead and save it. And if you're looking at the the Parallax tutorial, you'll notice there's actually chapters in it. So let me go to the desktop here. And so what I want to do is I'm going to start naming these sketches a little bit more descriptive, since they have, for each chapter, there's like an activity 1, 2, 3, and so we can't call them activity 1, 2, 3 anymore, or else it doesn't make sense. So I'm actually going to call this chapter 2, and then this is activity 2, and we'll just call it LED blinking. Okay? And let's go ahead and do this. So the first thing that I'm going to do is I'm going to come into my setup, and whenever I access the I/O, I always like to have the serial monitor going, because I'm going to be able to print stuff to the screen in order to kind of tell me what's happening with what's going on my system. Okay, so I'm going to go ahead and set up the serial monitor here by doing serial and then our traditional begin, and this is just a nice way to kind of debug things. So let's go ahead and go serial.begin, dot begin and set it up to be 9600, and then I'm going to go ahead and do serial.print, and I'm going to do this activity to LED blinking, and I always do that so that I know that it's running the program that I think it is. And now what I'm going to do is I'm going to use this new function called pin mode, and all I do on this is I give it the actual pin number that I'm going to mess with, that I'm going to configure. So I'll do 13, and then I give it the keyword input or output, and in this case I'm going to do output. And I do it in all caps, and notice that it turns blue, so the development environment noticed that it was a keyword. And I have just now set up pin 13 as an output. So great. And what I can do now is let's do the exact same thing on pin 12, and you can do it by copy and paste. And now I have set up pin 12 as an output, and they're ready to go. So now I'm sitting there going, well, how do I drive it to a high or low? And I use our other function that we just learned, which is going to be called digital write. And the way that this digital write works is the first argument is going to be the pin number. So let's go ahead and write to pin 13, and then I'm going to set it to high. And what that's going to do is it's going to turn on LED on pin 13. And okay, life is good. So now let's go ahead and copy and paste that and do it for pin 12, and then we'll do that. But when I run my program, they're just going to turn on and off, or they're just going to turn on. So what I'd like to do is have it kind of blink back and forth. So let's go ahead and go back before that and do a print where I'm going to say turning LEDs on, and then I can kind of track what's going on. Because I just turned them on, let's go ahead and now wait a second and then turn them off. So I can wait a second by doing a delay of 1,000 milliseconds using our delay function. And I've basically turned them on and waited. And now with a copy and paste, I can simply say, all right, now let's turn them off. And all I do there is I do a digital write to pin 13, and I say low. And the keyword turns blue, so the Arduino development environment recognizes it. And I can update my comment right here, and this should work. So let's go ahead and fire this up. I got my board all plugged in here, and it's going to work. And let's see, I'll go ahead and I'll turn on the camera here so that you can see this. And I also want to get my digital monitor up, or my serial monitor. All right, here we go. Activity 2, LEDs blinking, and on and off. And here we are. So check this out. I have my LEDs on here, and they're both turning on, both turning off at a rate of 1 second. I did it. Pretty simple, pretty straightforward. And now, why don't you go ahead and do it? So go ahead and pause the video and code up an Arduino sketch to configure pins 12 and 13 as outputs using the pin mode, and then use the digital write to turn them on and off at a rate of 1 second, and then go ahead and print something to the serial monitor like I did so that you can kind of track what's going on. So go ahead and do that.